So in the next question, we have to prove that cosec theta minus cot theta whole square equals to 1 minus cos theta upon 1 plus cos theta. So whenever such type of question comes where we have to prove LHS equal to RHS, what we are going to do is that we will start with LHS and then we'll prove it is equals to RHS. Suppose we are not able to prove LHS equal to RHS, then we have another way. We can prove it from RHS to LHS. And there are some times where suppose you are not able to do that also. Then what we can do is we can take LHS, solve it till some point, and then again take RHS and prove it equals to the same. So in that case, we can say that things which are equal to the same thing are equal to one another, and these are the three ways by which we can prove these type of questions. So let's start with this question, where we have to prove that cosec theta minus cot theta whole square equals to 1 minus cos theta upon 1 plus cos theta. We'll take LHS, which is cosec theta minus cot theta whole square. Now, while proving such type of question, always keep in mind that what you have to prove and in what trigonometric ratio term we have to prove. As we can see here, we have to prove in terms of cos theta. So we'll convert cosec theta and cot theta in terms of sine and cos. So cosec theta can be written as 1 upon sine theta, and cot theta can be written as cos theta upon sine theta whole square. Take LCM, we'll get sine theta, this will be 1 minus cos theta whole square. Now what we observe, we can write it as 1 minus cos theta whole square upon sine square theta. We need here 1 minus cos theta, and what we observe here is we are having 1 minus cos theta whole square. That means one of the power will get cancelled, and the denominator is in terms of cos. So what we'll do, we'll convert the sine square theta in terms of cos using the identity. So we can write it as 1 minus cos theta whole square upon 1 minus cos square theta. Then we'll use a square minus b square identity, and we can write 1 minus cos square theta as 1 minus cos theta into 1 plus cos theta. Now here, one of the power from numerator and 1 minus cos theta will get cancelled, and the value of it will be 1 minus cos theta upon 1 plus cos theta, which is equals to RHS. Moving to the next question, we have to prove that cos A upon 1 plus sin A plus 1 plus sin A upon cos A equals to 2 times sec A. Let's start with LHS, which is cos A upon 1 plus sin A plus 1 plus sin A upon cos A. Now we have to prove the RHS in terms of sec A, and sec A is a reciprocal of cos A. So we'll take LCM of the 1 plus sin A and cos A, which will be 1 plus sin A into cos A. Now this can be written as cos square A plus cos A is a common factor, it will be 1 plus sin A whole square. Now when we expand the numerator, we'll get 1 plus sin square A plus 2 sin A upon, this will be 1 plus sin A into cos A. Now we know that sin square theta plus cos square theta is 1. So here sin square A plus cos square A, that will be equals to 1. So we can write it as 1 plus 2 sin A upon 1 plus sin A into cos A, which can be written as 2 plus 2 sin A upon 1 plus sin A into cos A. Now from the numerator we can take 2 common, it will be 1 plus sin A upon 1 plus sin A into cos A. We can cancel 1 plus sin A and 1 plus sin A. We will get 2 upon cos A, which we can write it as 2 times sec, which is RHS, as we know that sec is 1 upon cos A. Moving to the next question, we have to prove that tan theta upon 1 minus cot theta plus cot theta upon 1 minus tan theta equals to 1 plus sec theta into cosec theta. Now our RHS is sec and cosec, which is the reciprocal of sine and cos. So here we can solve it in two ways. Either you can convert your LHS completely in terms of tan or cot, or you can convert it into sine and cos. We are going to convert it into sine and cos, and then we are going to solve it. So here LHS we have tan theta upon 1 minus cot theta plus cot theta upon 1 minus tan theta. We can write tan theta as sine theta upon cos theta, and 1 minus cot theta can be written as cos theta upon sine theta, plus cot theta can be written as cos theta upon sine theta, upon 1 minus tan theta can be written as sine theta upon cos theta. Now if you will take LCM of denominator, we can write it as sine theta minus cos theta upon sine theta, plus this will be cos theta upon sine theta upon cos theta minus sine theta upon cos theta. Now here when we simplify it, we will get sine square theta upon cos theta into sine theta minus cos theta plus cos square theta upon, this will be cos theta minus sine theta into sine theta. If you will rearrange the second term here, we can write it as sine square theta upon cos theta into sine theta minus cos theta plus cos square theta upon cos theta minus sine theta. Now here in this case, what we can do is, rather than writing cos theta minus sine theta, if I will write it as sine theta minus cos theta, then this plus sine we can write it as minus, and this will become sine theta minus cos theta into sine theta. Now take LCM. So LCM will be sine theta into cos theta and sine theta minus cos theta. Your numerator will become sine cube theta minus cos cube theta. Now here we know one identity, that a cube minus b cube, that will be a plus b into a square plus ab plus b square. And if we use that identity on sine cube theta minus cos cube theta, we will get sine theta minus cos theta into sine square theta plus cos square theta plus sine theta into cos theta. That will be divided by sine theta into cos theta into sine theta minus cos theta. Now we can cancel here sine theta minus cos theta and sine theta minus cos theta in the numerator and denominator. And we know that sine square theta plus cos square theta equals to 1. So we can write here it as 1 plus sine theta cos theta divided by sine theta into cos theta, which can be written as 1 upon sine theta cos theta plus sine theta cos theta upon sine theta into cos theta, which can be written as cosec theta into sec theta plus 1, which is our RHS. Let's move to the next question. Here we have proved that cos A minus sin A plus 1 upon cos A plus sin A minus 1 equals to cosec A plus cot A. Now these type of question, whenever it comes, we'll have to use a logic where we'll be converting our LHS in terms of cosec and cot. In order to convert it into cosec and cot, we are going to divide the numerator and denominator of LHS by sin A. So here in the LHS, it is given cos A minus sin A plus 1 upon cos A plus sin A minus 1. On dividing numerator and denominator by sin A, we will get cos A upon sin A minus sin A upon sin A plus 1 upon sin A, which will be divided by cos A upon sin A plus sin A upon sin A minus 1 upon sin A, which can be written as cot A minus 1 plus cosec A divided by cot A plus 1 minus cosec A. We'll write it as cosec A plus cot A minus 1 upon cot A plus 1 minus cosec A. Now one thing we need to remember that whenever such type of question comes, we are not going to do any change in the denominator part, and then in the numerator we'll be replacing 1 as cosec square A minus cot square A, which is the identity, and which further we'll be writing it as cosec A minus cot A into cosec A plus cot A, and then we will solve. So let's do that. So this will be equals to cosec A plus cot A minus cosec square A minus cot square A divided by cot A plus 1 minus cosec A. Now from the numerator, what we can do is we can write it as cosec A plus cot A minus, this can be written as cosec A plus cot A into cosec A minus cot A, which will be divided by cot A plus 1 minus cosec A. Now from the numerator we can take cosec A plus cot A common. We will get 1 minus cosec A plus cot A upon, that will be cot A plus 1 minus cosec A. Now what we observe that 1 minus cosec A plus cot A and 1 minus cosec A plus cot A is same in the numerator and denominator. So we can cancel out these factors and we will get the value as cosec A plus cot A, which is RHS. This is how we can prove this question. Now sometime what happens, they may ask you to prove it not in terms of cosec plus cot rather than sin and cos. So in that case, what you can do is you can write cosec A as 1 upon sin A plus cot A as cos A upon sin A, and it will become 1 plus cos A upon sin A. So this is also one way in which you can prove it. In the next question, you have to prove that the square root of 1 plus sin A upon 1 minus sin A equals to ck plus tan A. So we'll start with LHS, where we have 1 plus sin A upon 1 minus sin A. In order to prove this, what we are going to do, we are going to multiply in the numerator and denominator by 1 plus sin A, which will give us 1 plus sin A whole square upon 1 minus sin square A, as we know that 1 minus sin A into 1 plus sin A will be equals to 1 minus sin square A if you use A square minus B square identity. Next, if you will take square root of it, you can write it as a square root of 1 plus sin A whole square upon square root of 1 minus sin square A. Now, it can be written as cos square A using the identity. So this will be cos square A, which can be further written as 1 plus sin A upon cos A. Now you can write it as 1 upon cos A plus sin A upon cos A, and that can be written as ck plus tan A, which is our RHS. The next question is, prove that sin A plus cos ck whole square plus cos A plus ck whole square equals to 7 plus tan square A plus cot square A. Let's start with LHS. So we have sin A plus cos ck whole square plus cos A plus ck whole square. If we'll expand it using the identity a plus b whole square and a minus b whole square, we know that a plus b whole square is a square plus b square plus 2ab. So if we use that identity and expand, we will get sin square a plus cosec square a plus 2 sin a into cosec a plus cos square a plus sec square a plus 2 times cos a into sec a. Now we also know that sin square a plus cos square a is 1. Then cosec square a is 1 plus cot square a, and sec square a is 1 plus tan square a. And also we know that sin a into cosec a equals to 1 along with ck into cos a, that is also 1. So these are the relations which we are going to use in this particular question, and if we'll use that, we'll be getting sin square a plus cos square a will be 1 plus cosec square a, we can write it as 1 plus cot square a is 2 into sin a into cosec a is 1 plus sec square a, we can write 1 plus tan square a, and then 2 cos a into sec we can write 1, which will be 2 plus cot square a plus 2 plus tan square a plus 1 plus 2. When you add it, you will get it as 7 plus tan square a plus cot square a, which is the RHS. The next question is, prove that 1 plus tan square a upon 1 plus cot square a equals to 1 minus tan A upon 1 minus cot A whole square equals to tan square. So when we have such type of question, what we are going to do? We are going to take LHS and we are going to prove it is equals to tan square A, and we'll be also taking this 1 minus tan A upon 1 minus cot A whole square, and we'll also prove it as tan square A. So let's take 1 plus tan square A upon 1 plus cot square A. We can write it as 1 plus tan square A upon 1 plus this cot square A can be written as 1 upon 1 plus tan square A. As we know that cot A is 1 upon tan A. So cot square A will be 1 upon tan square A, which can be written as 1 plus tan square A upon, if you take LCM, it is tan square A, it will be tan square A plus 1. Here we can cancel 1 plus tan square A and tan square A plus 1 as addition is commutative, and we'll get the value of it as tan square A. Now we'll take 1 minus tan A upon 1 minus cot A whole square, and again we'll write cot A as 1 by tan A. We can write this as 1 minus tan A upon 1 minus 1 upon tan A whole square, which will be 1 minus tan A upon tan A minus 1 upon tan A whole square. Now here this 1 minus tan A and tan A minus 1, it will cancel minus 1 time, and so the value of it will become minus of tan A whole square, which is nothing but tan square. Therefore we can write 1 plus tan square A upon 1 plus cot square A equals to 1 minus tan A upon 1 minus cot A whole square equals to tan square A. And this is how we can prove this particular question.